Starting now. Okay. Verify that 6 minus I is the root of the following equation: z squared plus 12z plus 37. Hence, find the other root. So what we're going to do here is we're going to do the minus b formula. Minus b plus or minus the square root of b squared minus 4ac. We're also going to do is divide that by 2a. Now, you got to compare it. The number that comes in front of the z squared is a, the number that comes in front of the z is b, and the number that comes last is c. Okay? A equals 1, b equals 12, c equals 37. Once you've done that, you then got to put all these numbers into the formula. So you're going to have minus 12 plus or minus the square root of b squared, which is going to be 12 squared, minus 4 times 1 times 37, all over 2 times 1. Okay? Unlike regular minus b formulas, you can't just put this all in one go because it'll come out as a maths error. So what you have to do instead is you have to put in the inside part on its own first, okay? So the inside part on its own is going to be 144, which is 12 squared minus 4 times 37. And it should come out as a number 1, 4, 9, 16, some number like that. It comes out as 4. Okay? So it's going to be minus 12 plus or minus square root of minus 4 all over 2. Now the key thing to remember is, what would you do if it was plus 4? If it was plus 4, root 4 is 2. But because it's minus 4, it's 2i. That's the difference, okay? So what we're going to get next is minus 12 plus 2i, minus 12 minus 2i, all over 2. And when you divide it by 2, you get minus 6 plus I. And then you're going to get minus 6 minus I. Any questions? Happy enough with that? Okay guys, we're going to do one more, then we'll move on to the next type of question on this exercise. Okay, question. Okay, next one. Express this in the form p plus qi. Alright, so guys, you got to multiply the top and bottom by its conjugates. So Kim, what's the conjugate of this one? What you multiply top and bottom by?
1 plus 3i.
1 plus 3i. Okay, now that you've done that, can you call me out what happens when you multiply them out?
1 by 1 is 1. 1 by 3i is 3i.
3i. After that?
7 by 1, 3, 7i.
And then 7i by 3i?
21i squared.
21i squared, and that's also known as what number?
Minus 1.
So 21 times minus 1? Minus 21, fair enough, okay, it's good. Okay, next one then, 1 by 1?
1.
By 3i?
Plus 3i.
And then this one here?
Minus 3i.
Minus 3i, then after that?
9i. Minus 9i squared.
Minus 9i squared, alright, we'll just put the 9i squared to the side for a minute. Okay, minus 9i squared is going to be minus 9 times minus 1, which gets us plus 9. Now what should always happen is the middle part should cancel off, which it does. So what we're going to be left with is 1 minus 21 minus 20, 3i plus 7i, 10i, and then 1 plus 9, 10. Okay guys, so we have minus 20 plus 10i over 10. Minus 20 divided by 10 guys?
Minus 2.
Minus 2, 10i divided by 10? I. It's going to be minus 2 plus I. Now that we've done that, okay, also the second part is making us do is, it's basically saying, well, this is the answer to part A, but I also want you to prove that part A is a root of part A is the same here. I want you to prove that this number here is a root of this equation here. So once again, even if you didn't manage to get the first part, lads, there's no reason why you can't attempt the second part. Okay, because you can just get both roots anyway. So what we're going to do next is we're going to say A is 1, B is 4, and C is 5. Okay, then we have minus B plus or minus the square root of b squared minus 4ac all over 2a. Okay, so Peter, what's minus b?
It's minus 4.
Minus 4 plus or minus the square root of? 4 squared, yeah. Minus?
4 bracket 1 bracket 5.
Okay, all over 2 bracket 1, okay. In your calculator, you'd put this part in to your calculator only. Kane? What's 4 squared? And what's 16 minus 20? Minus 4, okay. Square root of minus 4 all over 2. Now what's the square root of minus 4?
2i.
2i. So we're going to have minus 4 plus or minus 2i all over 2. Now how do we finish this off then? Minus 2 plus or minus I. Or minus 2 plus I. Minus 2 minus I.
You can do, yeah.